Welcome to All You Know Space. Ever wonder how stars, those glittering jewels in the night sky, come into existence? Let's dive into it. The birth of a star is a cosmic marvel that begins in the vast expanses of space, within massive clouds of gas and dust known as nebulae. These nebulae are the cradles of star formation, brimming with the raw materials needed to create a star. Within each nebula, gravity plays the role of the great gatherer, pulling together particles of gas and dust. As these particles coalesce, they form a dense core known as a protostar. This protostar is much like a baby star, taking its first steps towards, so to speak. Now, the protostar isn't a star yet. It needs to grow, and for that, it continues to accumulate matter from the surrounding nebula. As more and more material falls into the protostar, its core becomes increasingly dense and hot. This is where the magic, or rather the physics, begins to happen. When the core of the protostar reaches high enough temperatures and pressures, a process called nuclear fusion starts. This fusion is the heart of a star, the source its power. It's where hydrogen atoms come together to form helium, releasing a tremendous amount of energy in the process. This energy pushes outward, balancing the inward pull of gravity and preventing the star from collapsing. And voila, a star born. It begins to shine, powered by the light and heat generated by nuclear fusion in its core. This newly minted star is now ready to embark on its journey through the cosmos, shining brightly for millions to billions of years depending on its size. So the birth of a star is a spectacular event, a cosmic dance of elements, gravity, and energy. It's a testament to the dynamic and ever-evolving nature of our universe, where new stars are constantly being born, even as others fade away. Once a star is born, it lives a long, fiery life. But how long, you ask? Let's find out. The life of a star is a tale of cosmic balance, a dance between gravity and pressure. The gravity pulls everything inward, trying to collapse the star, while the pressure from the nuclear reactions in the core push outward, resisting the gravitational collapse. This delicate balance factors into how long a star lives, and it all depends on the star's mass. Imagine a star as a celestial being, burning with the energy of millions of nuclear bombs every second. The larger the star, the more intense the nuclear reaction at its core, and the brighter it burns. But this brightness comes at a cost. Larger stars burn through their nuclear fuel much faster than smaller ones, leading to a shorter lifespan. In a sense, they live fast and die young. On the other end of the spectrum, smaller stars, often referred to as dwarf stars, burn their fuel at a much slower rate. They may not shine as brightly as their larger counterparts, but they make up for it in longevity. These tiny cosmic firecrackers can keep burning for hundreds of billions of years, far longer than the current age of the universe. Our sun, a medium-sized star, strikes a balance between these two extremes. It's been burning for about 4.5 billion years, and scientists estimate it has about 5.5 billion years left before it exhausts its nuclear fuel. In the grand cosmic scale, it's enjoying a comfortable middle age. But no matter the size, every star must eventually face the same fate. The nuclear fuel in the core will one day be exhausted, and the star will no longer be able to resist the inward pull of gravity. So, stars, just like us, have finite lives. But what happens when a star's life ends? Let's delve into that in our next segment. Scene script. Like all things in the universe, stars too meet their end. But how does this happen? Let's unravel this cosmic mystery. Stars, despite their celestial grandeur, are not eternal. They have a life cycle, much like us. Their demise is dictated by their mass, but regardless of size, all stars go through a dramatic transformation. Let's start with smaller stars, those up to about 8 times the mass of our sun. As they exhaust their nuclear fuel, these stars swell into a phase known as red giants. This is a phase of expansion and cooling where the star's outer layers are puffed up, turning it into a giant glowing orb. But this stage isn't permanent. Over time, these outer layers are expelled, creating a beautiful, gaseous envelope around the core. This picturesque phenomenon is known as a planetary nebula. What remains is a dense, hot core, which we call a white dwarf. This is the final resting state of a small star, slowly cooling over billions of years, fading into the cosmic backdrop. Now let's turn our attention to the larger stars, those more than 8 times the mass of our sun. These behemoths meet a more explosive end. When they exhaust their nuclear fuel, unlike their smaller counterparts, they don't gently shed their outer layers. Instead, they collapse under their own immense gravity, resulting in a cataclysmic explosion known as a supernova. This is one of the universe's most spectacular fireworks, outshining entire galaxies for brief periods. The aftermath of this stellar explosion can leave behind a neutron star, an incredibly dense object composed primarily of neutrons, but if the star was massive enough, something even more intriguing can occur. The core might collapse so dramatically that it forms a black hole, a region of space where gravity is so strong that nothing, not even light, can escape. So the death of a star is as dramatic as its birth, a cosmic spectacle of unimaginable proportions. But wait, the story doesn't end with the death of a star. There's an afterlife too. Now let's journey into the celestial afterlife, where stars, despite their demise, continue to astound us. The remnants of these celestial bodies take on fascinating forms, from white dwarfs to neutron stars and even the enigmatic black holes. Picture a star, much like our own sun, at the end of its life cycle. It has exhausted its nuclear fuel and shed its outer layers into the cosmos, leaving behind a hot core. This core, known as a white dwarf, is incredibly dense. Despite being similar in size to Earth, it holds about half the mass of the sun. As time passes, spanning billions of years, these white dwarfs cool down and fade into obscurity. They transform into black dwarfs, celestial bodies so dim they are virtually impossible to detect against the backdrop of the universe. But what if the star was larger? Let's say between about 1.5 and 3 times the mass of the sun. Well, its fate would be different. Its core would collapse under gravity, and its outer layers would explode in a supernova. What remains is a neutron star, an object so dense that a teaspoon of its matter would weigh as much as a mountain. Some neutron stars spin rapidly and emit beams of radiation from their poles. We see these as pulsars, cosmic lighthouses blinking in the vast sea of the universe. And then, we have the most massive stars, those more than 3 times the mass of the sun, their destiny to become black holes, regions of space where gravity is so strong that nothing, not even light, can escape their pull. They are the ultimate cosmic vanishing act, their existence known only by their effect on the space and matter around them. So, even in death, stars continue to fascinate us with their cosmic transformations. The afterlife of stars is a testament to the magnificent and complex cycles at play in our universe, a ballet of birth, life, death, and rebirth on a cosmic scale. Before we wrap up, here's a quick, mind-blowing fact about space. Let's take a moment to consider the sheer scale of our universe, a concept so vast, it's nearly incomprehensible. Now think about the grains of sand on a beach. Each tiny particle, countless in number, stretching as far as the eye can see. Now imagine every beach on our planet, from the sun-soaked shores of California to the pristine stretches of white in Australia to the rocky coasts of Iceland. Every grain of sand, on every beach, everywhere on Earth. The number is staggering, isn't it? Well, prepare for a cosmic revelation. There are more stars in the universe than there are grains of sand on all the beaches on Earth. Yes, you heard that right. The number of stars out there in the cosmos far exceeds the number of all the grains of sand on Earth. The universe in its vast expanse is home to billions upon billions, even trillions of galaxies. Each of these galaxies houses billions of stars. When we begin to multiply those numbers, we start to get a sense of the unimaginable scale of our universe. Now here's another twist. This fact doesn't even account for the number of planets, asteroids, comets, and other celestial bodies that populate our universe. So, when we say the universe is vast, we mean it's mind-bogglingly, unimaginably vast. And each of these stars, each of these grains of cosmic sand has its own story. A story of birth, life, death, and the afterlife. A process that we've explored today through the life cycle of stars. Isn't that amazing? The universe never ceases to surprise us. It's a cosmic playground waiting for us to discover its secrets, fostering an unending sense of curiosity and wonder. So, join us on this journey of cosmic exploration. Remember to subscribe for more fascinating space content. Until next time, keep looking up.